Hey everyone, welcome to today's Explainer. I am absolutely thrilled to have you here, especially all our 8th graders tuning in. Today we're tackling the Godly Learner's Guide to Graphing, and we're zeroing in on intersects and intercepts. Look, whether you're totally a math whiz or just someone looking for a simple, no-nonsense way to understand graphing, you are in the exact right place. Okay, let's dive into this, because what we're going to learn today isn't just about plotting random dots on a grid, it's about finding our way with absolute, undeniable accuracy right from the start. So, let's start with a really powerful concept from Psalm 119. Your word is a lamp to my feet and a light to my path. Now, the Godly Learner's curriculum uses this metaphor for a very specific reason. I mean, think about what a lamp actually does when you're stumbling down a pitch-black trail. It highlights exactly where you are, right? It shows you precisely where to step next. Basically, it gives you reliable checkpoints. The curriculum frames life very much like that path, a path that desperately needs reliable spiritual checkpoints so we don't wander off into the weeds. Without a light, well, we stumble. And in a really similar way, when we're mapping out mathematical equations, we absolutely need a reliable lamp too. We need specific, undeniable checkpoints to make sure our line is heading exactly where it's supposed to go.
Section 1. The Path and Intercepts, TEKS 8.3F, Checkpoints. Smoothly transitioning from that guiding light straight into our algebra lesson, let me ask you a question. When you stare down a blank graphing grid, how do you actually know where a line begins and ends? How do you know for sure you're laying down your path correctly?
Well, the answer comes down to one word: intercepts. By definition, intercepts are the exact points where a line crosses the x-axis and the y-axis. They literally act as our critical starting and stopping points. Honestly, this right here, this is the big idea of our entire explainer today. Intercepts are the ultimate checkpoints that keep your graphing work totally grounded and perfectly accurate. If your graph doesn't hit the correct intercepts, you instantly know something's off. Actually, scratch that. It's more like they're the solid anchor points of your mathematical path.
And you know what's cool? This brilliantly illustrates that intercepts aren't just abstract ideas floating around in some dusty math book. They mirror real-world checkpoints. When a function has a starting point or a stopping point, we use intercepts to find them. Think about, say, a car driving until the tank is completely empty. That agonizing moment the gas hits zero, that's an intercept. Or imagine a brand new business that's been pouring money into getting started, and finally, they make enough profit to cover all their costs. That exact moment they break even, yep, that's an intercept too. These show us exactly when something important begins or ends in our daily lives.
Section 2. Finding your x and y. The simple rules. So, how do we actually find these magical anchor points? Well, get excited because finding these mathematical checkpoints is incredibly easy. We just use a super simple two-part rule. Now, what's really interesting about this slide is the perfect symmetry. It's all about an inverse relationship. To find the y-intercept, you just set x to 0. And to find the x-intercept, you set y to 0. See how that works? It's perfectly balanced. If you want to know where the line crosses the y-axis, you just pretend x doesn't exist for a second, you make it 0. And if you want the x-axis crossing, you do the exact same thing to y. It's honestly like flipping a switch to light up exactly the point you need.
So the crucial takeaway here is that this translates into 3 incredibly straightforward steps to sketch literally any line. Step 1, set x equal to 0 to find your y value. Step 2, set y equal to 0 to find your x value. And step 3, plot both of those points on your graph and connect them with a nice straight line. That's the whole shebang. This method is incredibly quick and it is highly accurate, especially when your equations give you nice, clean, whole integers to work with. You find your 2 checkpoints and boom, your path is instantly clear.
Section 3. Graphing intercepts in action. Proving the method. Now that we've got our rules down, we're shifting into guided practice mode. I want you to follow along really closely here, because we're going to apply these exact steps to 3 real equations to see just how beautifully this works in action.
Okay, let's look at example 1. The equation is y equals 2x minus 6. Let's just break this down slowly. To find the y-intercept, we set x to 0. Well, 2 times 0 is just 0, right? Leaving us with y equals negative 6. So our first checkpoint is the coordinate 0, negative 6. Super simple. Now for the x-intercept. We set y to 0, so 0 equals 2x minus 6. We add 6 to both sides, which gives us 6 equals 2x. Divide by 2, and x equals 3. Meaning, our second checkpoint is the coordinate 3, 0. You just plot 0, negative 6, and 3, 0, connect them up, and you've got your perfect line.
Let's try example 2, and I'll speed things up a bit just to show you how fast and effortless this method becomes once you fully spot the pattern. Equation: y equals negative 4x plus 8. Y-intercept: make x 0.
Negative 4 times 0 is 0, leaving y equals 8. Boom! Our point is 0, 8. X-intercept, make y 0. 0 equals negative 4x plus 8. Move that 4x to the other side, so 4x equals 8. Divide by 4, x equals 2. Our point is 2, 0. Just like that, in literally a matter of seconds, we have our starting and stopping points.
All right, let's look at example 3. Now they're throwing a fraction at us, but do not let that intimidate you. The exact same checkpoint rules apply perfectly. Our equation is y equals 1/2 x minus 2. So set x to 0, 1/2 times 0 is 0, y equals negative 2. Our y-intercept is 0, negative 2. Now set y to 0. 0 equals 1/2 x minus 2. Add 2 to both sides, 2 equals 1/2 x. Now just multiply both sides by 2 to get rid of that fraction, and x equals 4. Our x-intercept is 4, 0. See? The rule never changes, and it absolutely never fails.
Section 4. Your turn to practice. Homework checkpoint. All right, scholars, we've mapped out our path together, and now I want you to take the reins. Get your pencils and paper ready, because in just a moment, I want you to pause this explainer and try applying these steps completely independently.
Here is your homework. For the first 4 equations, y equals 3x plus 6, y equals negative 2x plus 4, y equals 5 minus x, and y equals negative 1/2 x plus 1, I want you to find both the x and y intercepts using our 0 rule. And for that final equation, y equals 2x minus 8, I want you to actually sketch out the graph using only those intercepts you find. I have absolute 100% confidence in your ability to conquer these. You have the lamp, you have the rules, and you know exactly how to find those x and y checkpoints. So take your time, apply the steps, and you're going to do great.
Section 5. Education, Morality, and Peace. The Godly Learner. As we wrap up our math for today, I really want to zoom out from the algebra homework to look at life's much bigger picture. Let's dive into the core philosophy that actually structures this whole curriculum.
The curriculum poses a pretty bold statement right here. Education without morality will hurt. Heroesmart Academy intertwines biblical morality with education to ask a genuinely critical question. I mean, what is the actual point of knowing all the math and science in the world, or being highly educated if you lack a moral compass? If you just keep making bad choices that cause hurt? They argue that a sharp mind without any real direction is kind of like drawing a line perfectly straight, but entirely the wrong way.
To bring it all home, the curriculum draws on Romans 8, 6, and 7, promising peace of mind to those who keep their focus spiritual. And such a fascinating parallel, right? Just like we absolutely need mathematical intercepts to ensure our graphs are totally grounded, this series suggests we need spiritual checkpoints to ensure our choices lead to peace instead of hurt. Finding the right checkpoints in math gives you the correct answer. Finding them in life is meant to give you real peace of mind. So as you finish up your homework today, I'll leave you with this. Beyond the X and Y axis, what are the core checkpoints guiding your own path? Thank you so much for joining me for this explainer, and I'll catch you next time.